All right, y'all. In today's lesson, we're going to solve or look at the method that can solve all quadratic equations. And there is an actual formula for solving every single quadratic. So as we've looked at solving quadratics, see if I shrink the whole thing down there, we've looked at the first method, which was we could just graph the thing, the quadratic, and look for the zeros, the x-intercepts. So that worked pretty well. And then we looked at the square root method, and that worked pretty well also, but only with b equal to 0, so there couldn't be that middle term. Then we looked at factoring just a little bit. We'll deal with that in more detail later. Then we looked at completing the square yesterday. And that involved also the square root method. All right. Today we are going to use our last method that we will learn, which is the quadratic formula. The quadratic formula, even though it's taught last, is the best method to solve every single quadratic, because there's actually a formula called the quadratic formula that solves all of them. And I've got it written over here on the left-hand side. So we're looking at solving ax squared plus bx plus c. So a quadratic in standard form equal to 0. We can identify a, b, and c, and this is the formula that tells you what x is. Those two solutions, those places where it crosses the x-axis. It's just negative b plus minus square root of b squared minus 4ac all over 2a. So we just have to do a bunch of substitution. I do want to state, and we'll talk about why this is relevant later, that b squared minus 4ac has a name. And that name is called the discriminant. But we'll talk about that later. But if you ever hear me refer to the discriminant, I'm just talking about that number that is underneath the radical sign. So let's apply this equation to find some solutions. So here we go. Here's our first equation. It's quadratic and it's in standard form. Ax squared plus bx plus c equals 0. And what you want to do first, you want to identify your a, b, and c. So a equals whatever's in front of the x squared. In this case, there's nothing showing. That's an implied 1. And then b is whatever's in front of the x term. So in this case, a3. And the c is that constant term. That term that's at the end, in this case, a negative 5. And so I'm going to write down the quadratic formula again. Negative b plus minus square root b squared minus 4ac, the discriminant, all over 2a. And now we just solve for x. So we go x equals, and we go negative of b. Well, what's b? In this case, b is a 3. Then we've got our plus minus square root of, you want to put this in parentheses. It's a b squared, so we're going to go 3 squared minus 4. And I think it's also important to put parentheses when you plug in a. So a is a 1, substitute a, I should say. And when you substitute in c, like so. So this is my b, that's squared, minus 4 times a, which is 1, c, which is negative 5, and that is all over 2 times a. And again, a is a 1. And there we are. Now, all we have to do is simplify this, and we have the two solutions to this quadratic equation. So at this point, this is why the quadratic is such a great method, because it really is substitution and simplifying. So we have to take care of this squared first. So we're going to square that. I'm showing all the steps. We could do a couple of steps at once. 2 times 1 is 2, so we'll just write that in the denominator. -3 plus or minus square root of. Now we do have to make sure, and this is where we got to be careful. You got to do all this multiplication first. You can't do 9 minus 4 because of PEMDAS, our order of operations. We have to do all that multiplication. So it is -4 times 1, which is -4, and then -4 times -5, so it's 20. It's going to give you a plus 20 right here. In fact, whenever you have two negatives like this all multiplied together, you always get a positive. All right, so this is going to be a 9 plus 20, all over a 2. And we are done. 9 plus 20 is 29, all divided by 2. There's our two answers. Now, what you will see sometimes is this answer written a little bit differently, but for our purposes, the way it's written right now is just perfect. But this is the same thing as -3 over 2 plus minus root 29 over 2, like that. Just separating that fraction into its two parts with a common denominator of 2. Now this 29, if we could simplify that, break it down, for example, if that was the square root of 25, we'd rewrite that as just a 5, because you can square root 25. But 29 is a prime number, and so you can't simplify it. And so really, once you get to this point right here, you are done for this problem. Let's take a look at a couple more examples. These things are a piece of cake, but I would encourage you on your homework when you're trying to do it, have this formula right by your side, the quadratic formula. Solves every single quadratic. Then I would encourage you to write down what A is, what B is, and what C is. And then we just substitute. Put that negative sign because you got to do the opposite of B. Well, B is -6, so you get this you get minus a -6. So that's going to become positive in our next step. The B squared, I would always do that in my head if I could, or put it in parentheses to make sure you square the -6. It's going to be a positive as well. Then -4, here's my A, which is 1, and my C, which is 4, all over 2 times A. And now we're just simplifying. So there's that double negative, that's 6. I'm going to take -6 times -6, which is a positive. And look at all that stuff. That would be my next step. So you just do it at this point. -4 times 1 is -4. And -4 times 4 is -16. And 2 times 1 is 2. 6 plus or minus. We do the subtraction here. It looks like a 20. All over 2. Now, it'd be wonderful if that was the end of the problem, but it's not quite the end of the problem because square root of 20 can be broken down. It's a 4 times 5. And so I can square root the 4. So my final answer, 6 plus or minus, I square root the 4, which is 2. The 5 has to stay inside, all over 2. And those are my two answers. Now we could go one more step, and we should go one more step. And I want to show you there's a couple ways to think about this. But notice here that 6 is divisible by 2, and 2 is divisible by 2. So it's just like simplifying a fraction. But we have to simplify it all, so we would put 3 plus or minus root 5, and you could put it over 1, but we generally don't. So if everybody is divisible by that denominator, or even can be simplified with that denominator, you want to do that. There's a couple ways to think about why this works, but this is the mathematical reason, is if you have 6 plus or minus 2 root 5 over 2, in the numerator, you could actually factor a 2 out. Note this is still 2 times 3, which is 6, and 2 times root 5, which is 2 root 5. All divided by 2, and see now we have these common factors right here, and they cancel out. Okay, we can't cancel with stuff that's inside the radical. We have to cancel with something, in this case the 2, that is outside. So this 6 has a 2 in it, so does this 2. 6 is divisible by 2, 2 is divisible by 2, so we divide them both by the 2 in the denominator. So 3 plus or minus root 5, our best answer. And our last example, I do have 2 more. And the last example. In this last example, our A value is 2. So this is a little bit different. B is 7, C is 4, negative B plus or minus square root of B squared minus 4AC all over 2A. And we just start substituting. So we're going to get negative 7. So this negative, B is 7, plus or minus, we're going to have a 7 that's squared, the B value again, minus 4 times A, which is 2, times C, which is 4, all over 2 times A. And this is where it's a little different because A is 2, so it'll be 2 times 2, 4. And let's go ahead and clean this up. Square the 7, take care of that exponent, 49. And right here, we're going to do all that multiplication. So negative 4 times 2, that's negative 8. Negative 8 times 4, negative 32. All over 2 times 2, which is 4. Negative 7 plus or minus square root, what's that give us? 17, I think. That looks right. All over 4. And we're done. That's it for today. All you have to do is find A, B, and C, substitute them into the quadratic formula, and the equation is solved. And these formulas, or this formula in this particular case, they're very important because that is very programmable into a computer system or into a calculator to have it do a lot of the work for you. But we'll talk about that at a later time. For right now, just practice using the quadratic formula and then simplifying. So not quite our last example. Here we go. Write down the quadratic formula. Identify A. Identify B. Be careful on this one. That's a negative 1. And C, the negative 8. We'll do a little substitution. X equals negative of negative 1 plus or minus negative 1 squared minus 4 times A, which is 5, times C, which is negative 8, all over 2 times A. Double negatives, plus 1. Square a negative, you get a plus 1. And then you do this whole multiplication. Okay, so negative 4 times 5 is negative 20. Negative 20 times negative 8 is going to become a positive, and there'll be a what, plus 160. all over 2 times 5, 10. So 1 plus or minus the square root of 161 divided by 10. And I think 161 cannot be broken down any further. And I'm not going to spend time trying to break it down, but I'm pretty sure. Yeah, 161 I believe is 11 times. No, it's not that. Nah, 161 I think is prime. Let me check that real quick. Yeah, 161 is divisible. It's 7 times 23. And 7 and 23 are both prime, so it can't be broken down any further. By the way, I figured that out by typing into my calculator is 161 prime, and it tells you the factors right away. And then